So the Masterline method of uh, tool angles that we are going to discuss, it's very simple, and normally knowledge of trigonometry is required to solve or to find out angles or convert angles using this method, right? Uh, I'll make it simple for you. Okay. So basically, when we go ahead and convert the tool angles from ORS to ASA or from ASA to ORS, very important thing is that we have to uh, draw the tool geometry. So I'll request all of you to use, or you should um, have your pencil, scale, and your copy along with you when you're listening to this lecture. I would request you to draw a few things on the copy. Okay, then it will be more easier for you to understand. When you're doing it by your own, it will be more easier for you to understand. Okay, so please take a pen and paper, okay, or a pencil and paper, so that you can draw the diagrams, and definitely you can go ahead and solve it by your own. Okay, so let me start with the conversion of tool angles by the Masterline method. So the basic purpose of the conversion of the tool angles is to understand the actual geometry in any system of choice or convenience from the geometry of a tool expressed in any other systems. Okay, like suppose we have a tool nomenclature or tool signature given in a ORS, we should be able to find out what will be the tool signature in ASA, right? Because different types of systems are followed at different places. Okay, so there should be a communication between the different tool geometry. Okay, now that is why we go ahead. Now, please try to draw this diagram. This is a very simple diagram. Okay, it may look complicated to you. However, it's very simple, as we can see that this is your tool, and this is the tool which is drawn on the pi r plane. And what we have done is we have tried to convert it from ASA to ORS and vice versa. So let us name this as figure 4.1. Okay, so now what we have done in this figure 4.1 is we have done a section of the tool along the x-axis, and we have drawn the section in the pi x plane, right? This we all of us know what is the pi x plane and how the section looks in the pi x plane. Similarly, you draw a section along the pi y plane. So this is the pi y plane, and you draw the section of the pi y tool in the pi y plane. Okay, so now if you see that this is your rake angle, right? This is your rake angle, side rake angle, and this pi gamma y is your back rake angle, right? So now if we are looking into this diagram, if you see properly, also there are other angles which we need to draw. Let me go back to the slide once again. uh, that is the here we have not drawn the flank angles, flank clearance angles, that is alpha has not been drawn. The only reason is here we are not converting the alpha angles. Okay, we are only converting the rake angles. So whatever angles are required to be converted, we are only drawing those angles. Okay, so this is the gamma x, this is the gamma y. Okay, so as I have denoted this figure as 4.1, right? So because we are going to refer to this figure and later on. So again what we do is we section the tool along the pi o plane, that is perpendicular to the principal cutting edge, and we get the section here. This one is the section, and here we are getting the gamma O. Similarly, the view on the pi C plane is this one, So we get the inclination angle here. I believe all of you know this fact, that how we are going to do the sectioning of each of this sectioning or viewing, whatever. Okay, so these things are very clear to you. And this one is the view on the pi r plane. Pi r is the base plane, or the plane on which the tool is placed, right? That is a concept. Now what we have done here is, we have, starting from this pi x, this one, right, pi x, what we have done is, if you see this rake angle, okay, this rake surface, we have extended the rake surface, and this is your base plane, right? So this o dash od is your base plane, and we have extended this rake surface, and we have extended to such an extent that it intersects with this OD line, or the base line, right? Okay, again, this one, if we see, then what we have done here is, we have this gamma y, that is the rake, back rake, we have extended this gamma y so that it gets intersected with this O dash B dash, right? Now, what is this O and what is B? Let us come here on the pi r plane. Here we can see that this is the point where we are doing the sectioning of all the planes, okay, at point O. So we are considering this as point O on the pi r plane, and we are extending this line, right? And here at D dash, the rake angle intersects with the base plane, or we can say with the pi r at point D dash. So corresponding to D dash, if you project this D dash, you will get this point D here. Similarly, if you try to extend this gamma y rake line, and we try to intersect with the baseline, so this is the base, okay, so this will be our B dash, and if we take a projection of B dash on this vertical line, we'll get B. Now if we draw a line joining D and B, so BD line we have drawn, and let us see the significance of this BD line, right? So basically what happens here, again, if we draw the section of this uh, uh, pi O, that is the orthogonal rake angle, this is the orthogonal rake angle, we extend this orthogonal rake surface so that it intersects with this baseline. So this is the line. If we go ahead and project it perpendicularly, it will fall on this BD line. Again, if we consider this pi C plane, this is the view on the pi C plane. So if we try to view on the pi C plane, this is the angle of inclination, and the angle of inclination gets intersected with the base plane at this point A dash. So if we project this A dash here, that will also lie on the BD line. So if we extend, so that is why this line is called the master line for rake surface, right? So what is the master line? Master line is a line on which the rake surface intersects with the pi r plane. Is this thing clear to you? Then I can move ahead. Please respond uh, in case you have.
Sir, master line ta ekbar bole din.
Okay. See, here basically what we are trying to do is, we are using the rake surface. This is the rake surface. Okay, while I am saying, please someone please respond. Okay, so this is the rake
Yes,
surface. Okay, Now
Yes.
if we look into this gamma x rake surface, this is the inclination of the rake surface, and what we are doing is we are extending this inclination, and this is your base, right? This
Okay.
base means this is your pi r plane, right? Because the tool is placed on the pi r plane. So this rake surface intersects with the pi r plane at this point D.
Yes,
Again,
D1.
right? D dash, D dash. Okay. Again, for this gamma y, if you extend it, you try to intersect it with this pi r. This is again your pi r. This is again your pi r, this line. Okay. So if it intersects here, you are getting B dash. So what you're doing is you're on the section line. This is your section line for y. This is your section line for x. So on this section line, you take a projection of these points. D dash, you take the projection on the section line and you name it D. B dash, you take the projection on the section line and you name it B. You join these 2 points, you will get the master line. Now this master line is the intersection of the rake surface extended till the base. So suppose this is your rake surface. To be more precise, this is your rake surface, right? Okay. Now this surface, we
Yes.
know that it starts from this point. This is your highest point, and this one is
Yes.
your lowest point, as we have discussed earlier. Okay. So this is coming down. This is the inclination angle. This is the line of the inclination angle, right? And the entire thing has a slope downwards. So if you extend this to such an extent that it will touch the ground, right? Is it clear?
Okay. Okay.
Okay. So
Yes,
this
sir.
is the
Yes.
situation that it will touch the ground. So it will touch the ground along this line, BD line. So that line is called the master line for the rake surface. That means the rake
Okay.
surface, if it is extended, it will touch the pi r plane, which is the base plane or plane on which the horizontal plane on which the tool is placed. Okay. So you will get the line, that is master line. Again, if you see that for the orthogonal rake system, that is, this diagram represents the orthogonal rake system, wherein you're sectioning the principal cutting edge orthogonally, that is at 90 degree. We are getting the orthogonal
Yes, sir.
rake angle. Again, this orthogonal rake angle, if you orthogonal rake surface, if you extend it and you intersect it with the baseline, this again, if you project it perpendicularly here, like this is the intersecting point, this is the baseline, perpendicular to the baseline you need to project, perpendicular to the baseline. Okay, so try to draw it on your paper which you have with you, else it will be difficult for you to recall later on. Okay, as I am saying, you keep on drawing so that you can understand this better, because if you think that you will draw it later on, then it will be again difficult for you. In that case, you will need to again see the video. Okay, however, it will be better while I am explaining, I'll request you to draw it on the paper so that it becomes easier for you to remember. Okay, so we are drawing a perpendicular from this point C dash, and we'll see that perpendicular intersects at this master line at point C. Okay, again, if we see, again, if you see this, it will intersect at which point? At point where you have intersected, this O has intersected OC. This line is the section line that you have drawn for drawing the orthogonal rake angle. Okay, so this is the pi O plane. This is the section on the pi O plane. Okay, Again, if you are viewing the pi c plane, that is pi c plane is the principal cutting plane. If you take a view on the pi c plane, you will get this inclination angle. And again, if you extend this inclination angle till the baseline, you will get this point A dash. If you draw a perpendicular to O dash A dash, you will get a point A on this master line, right? Which you can again see, which intersects again with this line of this principal cutting edge, right?
Sir, I have a question.
Yes, go ahead.
Sir, in previous three cases, we saw that we are extending the means rake surface or the rake angle means the edge.
Yes,
And in this case, why you are doing the inclination angle?
because this in this case we do not have the rake angle. This is the inclination angle. Rake angle is always on the rake surface. Since this is the principal cutting edge and there is no surface here at this edge, this angle is called the inclination angle, right? This is not the rake angle. Rake surface is the pink portion that I have done on the diagram. That is the rake surface. Anywhere in this surface, if you want to find out the angle, that will be your rake angle, depending on the section that you are taking. Whether you are taking section along the pi o plane, section along the pi x plane, pi y plane, or pi n for normal rake angle. Okay. However, since we are just viewing, viewing means if you try to see from this direction on this principal cutting edge, okay, you place the tool in this manner and you see from this direction on the principal cutting edge, you will see a plane which will look something like this, and you will be able to see the inclination angle. This inclination angle is this lambda, right? And it is not your rake angle. The only reason
Rake
is
angle. Yes, sir.
the rake angle is on the rake surface. Is it clear?
Yes.
So the master
Yes,
line
sir.
method is clear now, right? How to draw the master line? Is it clear for all of you?
Yes, sir.
Okay, fine. So let us move ahead and let us see that how we can convert the tool angles from the master line. One more information you can see from here, that we have this thickness of the tool also that is given, which was not provided previously when we were drawing the slope diagram. This thickness T of the tool is also provided. Thickness of the shank, we can say, right? Using this, we can have the other angles. Now let us see that how we can go ahead with this. Now from this diagram 4.1, OD equals to, so let us consider here, let us concentrate at this point, gamma x. Gamma x is this one. So your gamma x here is this angle. So if I consider this, this is my T and this is the angle gamma x. So this is T and this is O dash and D dash. Fine. So if you want to find out tan gamma x, tan gamma x, tan gamma x will be equals to T by O dash D dash, right? Perpendicular by base, right? So I can write O dash D dash equals to T cot gamma x. Yes or no? Please respond. In case you have
Yes,
not
sir.
understood, I'll explain again. Okay. So
Internal alternate angle you took.
yes, this angle is equals to this angle. Okay. So alternate
Yes, sir.
angles. So since this was gamma x, this is also gamma x. So I took tan gamma x equals to T by O dash D dash. So that means O dash D dash will become T cot gamma x, right? Okay. So let us see this. So OD, O dash D dash, here O dash D dash, or here OD, this one OD, both are same, right? O dash D dash and OD both are same, so they have been named as OD is equals to T cot gamma x, right? Similarly, for this diagram, if I try to draw, so this is your this triangle, this angle is your gamma y angle, and this is your T, and this is your OB. I am writing OB instead of O dash B dash because we can see from here that O,
It is equal.
yes, O dash B dash and OB are equal, right? So I am writing O dash B, OB instead of O dash B dash. Okay. So similarly, we can write that OB equals to T cot gamma y, right? So OB equals to T cot gamma y. Again, OC equals to T cot gamma naught. OC equals to T cot gamma naught, right? I am not doing it again, so you know the process now. Next, OA equals to T cot lambda. OA is equals to T cot lambda. So now here we have got the values of OA, OB, OC, and OD, right? All these values we have got. Now let us look into means more simpler diagram. So this was figure 4.1 I named. So this figure is 4.2. So if we look into this diagram, figure 4.2, we can see that we now know the values of OA, OB, OC, and OD, right? Okay. So we can find out, if we want to find out the area of the triangle OAD, right? We can say that OAD equals to OAC plus OCD, right? We can add the
Yes, sir.
two areas, okay, right? So now, so here again we have we came to we can consider T as unity, okay? So if we consider T equals to 1, right, we can write OD equals to cot gamma x, OB equals to cot gamma y, OC equals to cot gamma naught, and OA equals to cot lambda, okay, for simplifying the issue, okay, for simplifying the problem. So now let us move ahead and see. So we are doing the conversion of the two angles from ASA to ORS, okay. So we have two values here, gamma naught and lambda in ORS. That is a function of gamma x and gamma y in ASA system. We have already done this using the slope method previously. So we can write gamma naught is a function of gamma x and gamma y.
Gamma y. Yes.
Similarly, lambda is a function of gamma x and gamma y, right? So here we have two equations. So gamma naught is a function of gamma x and gamma y, okay. So tan gamma naught equals to tan gamma x sine phi plus tan gamma y cos phi. Again, tan lambda equals to tan gamma x cos phi plus tan gamma y sine phi. These two equations are very common equations. We have already solved them using the slope method. Now let us look into this equation number 4.1. So with this figure which we have drawn previously, with the previous figure, this one. Now let us look into what are the angles I am talking about. So we are talking about gamma naught, gamma x, and gamma y. These three angles are important. So if we consider the triangle OBD, so if we consider a triangle OBD, this triangle, right? Why this triangle? Because OB is corresponding to your gamma y and OD is corresponding to gamma x. You may ask why we are only considering this triangle and not other triangles like OAC or some other triangle. You may ask. However, it is related to the parameters that are given in the question. In the question, it is given that gamma x and gamma y are there and gamma naught is there. Three angles are given. So corresponding to these three angles, you take the three lines OB, OD, and definitely you have to consider this master line. So this, see, if you consider this bigger triangle OC, this line is your
Orthogonal.
for gamma naught. So that will come
Yes,
inside.
sir. Orthogonal.
Okay, fine. So now you can divide this bigger triangle or area. If you want to find out the area of OBD, you can write triangle OBD equals to, or area of the triangle OBD equals to area of OBC plus OCD, right? You can write this. Okay.
Yes,
Now
sir.
you want to find out, if you want to find out the area of this triangle OBC, you will have to find out the area of or the height. That is, this is the height EC and the base is OB. So half into OB into EC. So there is 10 minutes left. After this lecture will be over. I'll request you to click on the same link so that we can continue, right? So OB into EC into half will give you the area of the triangle OBC. Similarly, the area of the triangle OCD can be found out equals to half into FC, that is the height, into OD. Let us see. Okay, so that is triangle OBD equals to triangle OBC plus triangle OCD, that is equals to half into OB into OD. Again, see here for this bigger triangle OBD. So this is a right angle triangle. So you can take any side as a height or the base. So here we can take OB as the height and OD as the base. So it becomes half into OB into OD. That is that area of that bigger triangle. So half into OB into OD equals to half into OB into CE plus half into OD into CF, or half into OB into OD is equals to, now let us see what CE is all about. In this CE is one, is the, again this, if you look into this angle is your phi angle. So this line and this line is making the phi angle. So perpendicular to this line and perpendicular to this line will also make an angle phi between them, right? Is this thing clear? We have already discussed these things previously. So now perpendicular to this angle, now the angle BEC is your phi angle. So if you want to find out EC becomes your sine of phi, OC sine of phi. So OC, this line OC sine phi is your this line. Okay, so this, if you are taking a projection here of this line on EC, okay, so this EC becomes OC sine phi, right? Similarly, this angle is the alternate angle. Okay, so CF becomes your OC cos phi, right? So if you are using your pen and paper, please try to write down this on this means beside this diagram. It was difficult here to accommodate all of those things in this same slide. However, you can use your copy to write it down. So now let us see. So what we have got is half OB into OD equals to half OB into OC sine phi plus half OD into OC cos phi. This thing every one of us have got. Now, if we divide this entire equation by uh, half is definitely getting cancelled out. Okay, we divide it by OB into OD into OC. So what we are going to get is 1 by OC. 1 by OC equals to 1 by OD sine phi 1 plus 1 by OB cos phi. Now let us look into these equations. Let us not go back to the diagram. We don't need to go back to the diagram. We have already solved. So from these equations, we have got these equations. So now we can directly put the value 1 by OC. 1 by OC is 1 by cot gamma naught. That is tan gamma naught, right? 1 by OD should be your 1 by cot gamma y. That is your tan gamma y, right? Sorry, not y, OD is gamma x. So 1 by tan gamma x. And OB, 1 by OB is 1 by cot gamma y. That will give you 1 by cot y. Sorry, 1 by cot gamma y is tan gamma y. Okay. So this equation is now proved. Okay, so this you have already, you can prove it using this Masterline. Similarly, you can prove that tan lambda equals to minus tan gamma x cos phi plus tan gamma y sin phi. So for that, let us go to equation, the same figure number 2. Okay, 4.2. Now triangle, what are the this is the lambda, gamma x and gamma y. So which should I take? This line corresponding to lambda, OA is corresponding to lambda, gamma x is your OD, and gamma y is your OB. I believe all of you have this thing clear in your mind, okay, about which one is your which line you should take for which angle. This OA corresponds to your lambda, OD corresponds to your gamma x, OB corresponds to your gamma y. So now we are going to take triangle OAD, or area of the triangle OAD equals to area of the triangle OAB plus area of the triangle OBD, right? So let us see, OAD equals to OAB plus OBD. So in the same manner, you can find out. So here this triangle here OAD, the perpendicular or the height, okay, the altitude is OM, right? OM here, that is the altitude. So here you can put here, let us see one thing here, that is OAD. This triangle is what I am talking about now. So if we look into this triangle, that will be OAD, OAD, this triangle, that is your base you can consider as AD, half into AD into OM. This you can consider, right? There is some printing mistake here, AG, okay? So OM, this will be M, okay? Or you can also consider this height, okay? This height you can consider here AG, right? Okay, rather we consider this height AG, okay? So this height, if you consider, you will get the value. So half into OD into AG equals to half into OB into OG, OB into OG, sorry, OB into OG is OAB, OAB, right? OAB, this is the triangle. So this is the height, OB is the base. Okay. Again, half into OB into OD. This is easily you can find out. This is a right angle triangle, OB into OD. Right. So from here, you can again find out the value of AG and OG as OA, AG, and OG as OA. AG becomes your OA sine phi, and OG becomes OA cos phi. Okay. Similarly, you put the values here and you will get this value proved. Okay. Right. So this, by this method, please try to do it yourself. Okay. And then you can convert both the equations in the matrix form. So from ORS, this is a ORS, to ASA, you can convert using the transformation matrix, that is sin phi cos phi minus cos phi sin phi. This is the transformation matrix that we are using. So using this matrix, you can always convert from the ORS to ASA. And suppose you want to convert it from a angles gamma x as a function of gamma naught and lambda, or gamma y as a function of gamma naught and lambda. In that case, you have to use the inverse of this transformation matrix, then you will be able to get. So time is about to finish. Okay, I'll request you to click on the same link again, and we can restart the class once again. Okay, thank you very much for attending. See you soon.